Greetings, everyone. Our senior design project is an advanced battery investigation sponsored by a local company, ThermoAnalytics. ThermoAnalytics is a leading developer of 3D thermal simulation software that is used in the aerospace, defense, and automotive industries. Our MTU Electrical and Computer Engineering Department advisor is Dr. Bergstrom, and our advisor from ThermoAnalytics is Dr. Adele. Our team members are Logan Canull, Bayleigh Purdy, Noah Hornfisher, and me, Jalen Vaughn. We were tasked with creating a standardized testing procedure to evaluate the performance of battery cells used in electrified vehicles. This performance data is then used to create equivalent models in a program such as MATLAB. The data and models can then be integrated into the thermal simulation software that our sponsor develops. With the global push for electrified vehicles, it is key that the major auto manufacturers are able to run highly accurate simulations of their EV designs. This project had many associated tasks, including setting up the lab equipment, creating a standard and adjustable load profile, creating a project and lab view for test automation, running the test to collect data, and writing clear documentation of lab procedure guides. We were given access to the Energy Resource Lab in the sub-basement of the Electrical Energy Resource Center on Tech's campus. There were a few key pieces of specialty equipment there that made this testing possible, including a large thermal chamber and an NHR 9200 battery tester. Our lab setup can be seen in the image on the screen. This diagram shows the data flow of our testing procedure. We created a load profile after researching various battery characterization methods and standard drive cycles. This profile is then loaded into the LabVIEW interfacing program that we created to configure the test. Lots of other test parameters are entered at this stage, including capacity and voltage levels. The battery tester then creates the load current profile, which is applied to the cells that are sitting in the controlled environment of the thermal chamber. Collected data includes load current, battery voltage, and battery surface temperature. Shown on the screen is a sample of the data we are collecting in the lab. Voltage, current, and temperature are shown over the length of the test, which can be quite long, approximately 40 hours for a full 3 temperature cycle using our current testing profile. Moving forward, our intention is that further battery testing can be completed in the future, after our current team has graduated and moved on. Extensive documentation, writing of standard operating procedures, and an effort to simplify the test configuration interface will make it easy for anyone to jump in and continue battery research. Adjusting test profiles and parameters, and obtaining more battery cells of different chemistries, capacities, and topologies will allow for a comprehensive library of battery models for our sponsor. This will allow them to push the boundaries of current electric vehicle research and design. Again, we would like to thank ThermoAnalytics for this research opportunity and our advisors for their continuous guidance throughout this project.